Hello good people, it is time to determine the equation for a straight line. It turns out that the length of an adult person's radius can be used to approximate their height. The radius is one of the two long bones in your forearm, the other being the ulna. And you thought you would be learning only mathematics here. The problem is asking us to determine the equation for the assumed linear relationship between the radius length and a person's height. Furthermore, we are asked to calculate the approximate height of a person whose radius is 24 centimeters long. To help us deal with this problem, we are also given some additional data in this box here on the right. Jake has a radius that is 20 centimeters long and he is 156 centimeters tall. Mike, on the other hand, has a radius that is 28 centimeters long and he is 194 centimeters tall. These ordered pairs represent coordinates that we can plot on a graph. What will go on the x and what will go on the y-axis? We want to use the radius length to approximate a person's height. We are saying, or we are assuming, that the person's height depends on the radius length. Therefore, the radius length will go on the x-axis and the person's height will go on the y-axis. Here are my axes. Note that they include discontinuities. The first reason for having them has to do with the space available on the screen. The second I will address towards the end of the video. Let me quickly plot the points for Jake and Mike and connect them with a straight line. Considering that the line, when read from left to right, is going up, I am expecting a positive gradient. What about the y-intercept? Due to the discontinuities, I cannot extend this line to see where it will hit the y-axis. Luckily, I can still calculate the y-intercept. But firstly, I need to calculate the gradient. And for that, I will need the formula for the gradient. I also need to decide which one is point 1 and which one is point 2. I'm going to make Jake point 1 and Mike point 2. That means that I will have 194 minus 156 over 28 minus 20. And that will give me 38 over 8, which is the same as 4.75. Now that I have the gradient for this line, I can calculate the y-intercept. I'm going to start with the general equation for any straight line. Seeing how I already know that the gradient is 4.75, I can write y equals 4.75x plus c. To solve for c, I need some values for y and x. I'm going to use 0.1 simply because the values are lower. And now I'm going to substitute. This means I will have 156 equals 4.75 multiplied by 20 plus c. This will give 156 equals 95 plus c. To transpose the 95, I need to subtract it from both sides. And that will give me 61 equals c. Now that I have both the gradient and the intercept for this line, I can write the equation for this line, and it is y equals 4.75x plus 61. We are not done yet. We have been asked to calculate the approximate height of somebody whose radius is 24 centimeters long. In this equation, y represents the person's height and x represents the length of their radius. So I'm going to say let x equal 24 and see what happens to y. This means that I will have y equals 4.75 multiplied by 24 plus 61. 4.75 multiplied by 24 is 114 plus 61 will give me 175. Based on the information provided within this problem, we could say that a person whose radius is 24 centimeters long will be approximately 175 centimeters tall. Now that I have solved the problem, I'm going to take a few moments to talk about these discontinuities on my axes. What would this graph look like if I did not have them? It would look something like this. Once again, here is the point for Jake at 20,156, and here is the point for Mike at 28,194. I have connected the 2 points and then used a dash line to see where it would hit the y-axis. And it appears to be somewhere around 60, which does match our equation. So why did I not do this in the first place? Well, in part because I was lazy and I wanted to draw a small graph. But there is another reason, and that is the context of the problem. Using the radius length to approximate somebody's height works for adults, not necessarily for children. And this formula, or more precisely, the data that we get from this formula, breaks down once we go past 150 centimeters. Let's think about what this line is actually telling us. It is telling me that somebody who does not have a radius, or has a radius of 0 centimeters, should be 60 centimeters tall. And that does not make sense. From a pure mathematical point of view, this equation is fine. We can have an intercept at 61. However, in everyday life, mathematics is always connected to some sort of context, and we have to keep that context in mind. In other words, do our numbers actually make sense for the problem that we are working on? That is all for now, and I will see you on the flip side.